Hi everyone. Today I would like to discuss the circle and related theorems. At the very beginning, we will start the definition of the circle. Let's see what the circle is. Circle. Actually, it is set of points in a plane that are same distance from a fixed point. What is this fixed point? Actually, this fixed point is called the center of the circle. Not only that, if we want, we can say it is a path of a point equidistant from the center. The path is called the, what is it? It is circumference. Actually, the path of this is the circumference of the circle. Okay. Now, let's go beyond that. The distance between the center to the circumference is a constant, or it is equidistance. Okay, then what is that distance? This distance is called the radius of the circle. Okay, now let's go to the next one. It is the diameter. What is diameter? The diameter is, if I draw a line through the center, the line is D to E. Actually, this length is called the diameter. What is the relationship between the radius and the diameter? If I take radius is R and the diameter is D, the diameter is equal to twice the radius. Okay. The next one is the chord. We will see what the chord is. A chord is a straight line joining 2 points on the circumference of a circle. Let's see here. A and B are 2 points on the circumference. If I draw a line from A to B or B to A, this is called the chord. Then the next one is arc. What is arc? Arc is a part of the circumference. Here A to B is a part of the circumference. It is called an arc. The smaller portion of the circumference is called the minor arc, and the larger portion of the circumference is called the major arc. Let's move to the next part. It is the sector. What is a sector? It's a portion of the area of the circle enclosed by 2 radii. O is the center, OP and OQ. They are 2 radii. Then the area enclosed by 2 radii is called the sector. This is the small part is called the minor sector, and the bigger part is called the major sector. Okay. Now we will go to the next one, the segment. What the segment is? If we draw a chord of a circle, here A to B is a chord. The area of the circle is divided to 2 parts. One part is smaller, in this case the other one is bigger. The smaller one is called the minor segment, the bigger one is called the major segment. Then the next one is tangent. What the tangent? Actually, tangent is a straight line that touches the circumference of a circle at one point. The angle between the tangent and the radius is 90 degrees. That means it's a straight line. Here, the tangent is a straight line which touches the circumference of the circle at one point. If we draw a radius to the point at which touches the circumference, both of them are perpendicular to each other. That means the angle between the radius and the tangent is 90 degrees. Now If we go to the other one, we have to know this one. The semicircle. Semicircle is a half of the circle. Here, AB is a diameter of the circle. If I consider one half is called the semicircle. Okay. Now, let's move to the circle theorems. The first theorem says the angle in a semicircle is a right angle. That means the angle is 90 degrees. Here, see, then AOC is a diameter. Then one of the parts is a semicircle. The angle at the circumference is 90. Not only this part, then if I connect it to the other side, then I'll take this point as D. ADC is equal to ABC is equal to 90 degrees. It's the theorem. Then I'll take it as theorem number 1. Okay. Let's move to the next theorem, the second theorem. However, the sequence of the theorem, if you want, we can change, but you have to know the theorems. Okay, the second theorem is theorem number 2. Actually, the second theorem is related to the angles in a circle. Okay, I'll draw a circle. This is a circle, and I'll take the center as O. Center as O. And we will consider AB as an arc. AB is an arc. The angle subtended by this arc at the center. That means the angle at the center and the angle at the circumference. This is the angle at the circumference. I'll take this one as C. What the theorem says, when two angles are subtended by the same arc, the angle at the center of a circle is twice the angle at the circumference. That means this angle is alpha. We can take this one as 2 alpha. As an example, if I draw a circle, this is a circle. The angle at the center and the angle at the circumference. If this angle is 30 degrees, we can say this is 60 degrees. This is the theorem, theorem number 2. Then the next theorem. The next theorem I am going to discuss, it is related to the angles subtended by the same arc O, angles at the same segment. Here, angles subtended by the same arc at the circumference are equal. AB is an arc. The angle subtended by AB at the circumference. One is at D, the other one is at C. They are same. This is alpha, this is alpha. Oh, not only these two angles, if you want, we can draw infinitely many angles like this. They are same. Okay. However, we can say in the other way, angles at the same segment. Here, if I connect AB, the angles at the same segments are equal. I'll take this one as theorem number. This is 3. Before we move to the next theorem, I would like to explain this quadrilateral. Quadrilateral related to the circles. Actually, it is called the cyclic quadrilateral. What the cyclic quadrilateral? If I draw a quadrilateral within a circle, all the vertices of the quadrilateral are on the circumference. I'll take A, B, C, D. All the vertices are on the circumference. This is called the cyclic quadrilateral. There is a circle theorem related to the cyclic quadrilateral. We will discuss what the theorem is. Actually, a cyclic quadrilateral is a quadrilateral with four vertices on the circumference of a circle. Already we discussed that. Opposite angles in a cyclic quadrilateral total is 180. That means if we add these two angles, if we add the opposite angles P and Q, P plus Q is 180 degrees, as well as X plus Y also 180 degrees. Next theorem is related to the angles in different segments. Actually, it is called the alternate segment theorem. We will discuss what this alternate segment theorem is. Here, the alternate segment is the angle between tangent and chord. Here, the chord is equal to the angle in the alternate segment. I'll explain that. Here, AT is a tangent to the circle and AB is a chord. Angle between the tangent and the chord is X. Then this angle is in the minor segment of this circle. However, this is equal to the angle in the alternate segment. That is the theorem. Here, this angle is equal to the other angle at the other segment. This is the theorem number 4. Okay. Then the last one I'll take it as theorem 5. The last one I'll take it as theorem number 5. It is related to the radius and the chord. Then if we draw a radius to the midpoint of a chord or the circle, they are perpendicular to each other. The radius through the midpoint of the chord will be bisect. The chord is at 90 degrees. That means this is 90 degrees. I have discussed the definition of the circle and the parts of the circles as well as related theorems of the circle. In my next video, I would like to discuss some questions related to the circle theorems and how to apply them for the different type of questions. Thanks for watching my video. Please subscribe to my channel to watch my new videos. Thank you.